First thing we're going to do now is just find the radius of the lake. We're just going to assume this is like a circle here, and then we're going to find the radius of that, and then we'll be using this sort of triangle shape here, and we'll find the volume of that triangle and take it away from what we get as the volume of the circle. So what we need to do is actually find the radius of this circle. So if we go from the end to about the middle there, that gives the radius as 0.018 kilometers, which is 18 meters. And then what we now, that's the radius, so we can use that to find the volume. And what we now need to do is find the length of the base of the triangle, like that, which comes out as 20 meters. And then we need to find the height of the triangle, so we can use half base times height to find the area of the triangle. So the height of the triangle comes out as 0.009 kilometers. So they're the measurements we'll be able to use to calculate the volume of the pool lake.
So I will explain to you how we found the depth of the lake side, of the lake side. We just use the software Google Earth to find it. We made some lines like this to show how here's the depth, and we just look at the difference between the extreme wave, and we can calculate that we got 2 meters of depth with Google Earth. This is a very good software, and we can rely on. So we can by this way find the depth and make our calculation by the way.
Cool. Alright. So the shape of the lake looks like this.
That's the top part of the flat face.
Looking on a bird's eye view, this is what it looks like. So what we're doing is we're assuming that it's going to be a circle in order to actually carry out our calculations. And we're going to take this point as the radius, as the center point of the circle, and measure the radius here, and then subtract this whole region, which is not the which is not part of the thing.
It's not got any water in it.
So we have used Google Earth to find the depth of the whole lake. So which is in 3D will probably look like this. So the depth here is 2 meters, right? And then the radius, we found it to be 18 meters. So we're going to use these two numbers to find the volume, and also we found the perimeter of the whole thing to be 127 meters.
But then the thing is, like the 2 meters, that's the depth. That's the depth, and the 18 meters is like the radius. You know what I'm saying? So like if you have like a ball here, and then like that's the floor level, like this distance is 2 meters. So like a radius in a circle, in a sphere, is like if you have a stick in the center, the end of the stick's got a point at the same distance any place around the circle, any place around the sphere. So if we've got that as 2 meters deep, then that means the face of it can't be 18 meters, because that's wrong. It can't be the radius. So it is a sphere, but what it is that the majority of the sphere goes on the top, and only a little bit of it goes on the bottom. That way it becomes 18. That big becomes 18 meters as radius, because that distance there is only 2 meters. So you can't have, like, from the center of the bird's eye view, you can't have there to there being 18 meters, and then from there down to the bottom of the lake only being 2 meters, because that's incorrect. Then it's got to be the same radius all the way around. So I think if we abandon like the sphere method and we just choose like doing the face method, it might be easier then.
Alright,
the problem we're having with the sphere is that it's not a perfect sphere. What we did earlier planning to do was to sort of chop it in half, but the problem is the floor doesn't cut the circle halfway through. It cuts the circle about there, because that's why we're getting 2 meters for that, and from the center outwards to the edge we're getting 18 meters.
Okay. How about we use this idea and we use it as a cylinder, because it's a cylinder.
Yeah, like a
because
cylinder.
Like the
So-
same as this, but just using cylinder.
if we know the diameter now
Yeah.
and we know the height,
Yeah.
we can just
It's a
estimate
great
it
Yeah.
using the diameter and the height,
Yeah.
and use the
Just
Yeah.
cutting this part. And,
yeah.
So what we need to do is like find the area of that and then times it by 2 meters, which is the depth.
yeah.
So volume is equals to 2 pi r squared h.
Yeah, that's it.
So-
So you can either find the volume of this whole cylinder and then find the volume of that part and subtract it, or you can just find the area of that and times it by the depth. I don't think that taking into 3D. So like if you call this like the circle, if you
Mhm.
find the area of this, I mean, how are we going to make this? I mean, if you have like a
Yeah, we have to.
if you have
we have
like
to make
if
the
you make that
yeah,
like,
that, we
like
have
that,
to do
that's
this.
a triangle.
Yeah.
So if we find
And we
the
got-
whole area,
yeah.
then we find that
Yeah,
area,
yeah, that's it.
and we take that away from the whole area, we'll get this area, and we times that by 2 meters. That will
And-
give us
and we
like
got
the depth.
The radius of 18 is there.
Yeah, the radius there. No, but we established that the radius can't be 18. It's got to be 2
Yeah.
because, well,
No,
No,
that's
good.
right,
The
sorry,
depth
yeah.
is 2,
the
but
depth,
the radius
the
is
radius
18.
Yeah, I'm still thinking as a sphere. Yeah, the radius is 18. So we can find the area of
Volume.
this here, this area here, and then times it by 2 meters, which is the depth.
Yeah.
And that should give us the depth. So if we have like this is the natural diagram, then if we make it more rounded off like just to that, because it's going to be quite difficult to find the
Yeah.
area of that unless we split it up. So if we round it off more narrower, so that's
Yeah,
more
and then we
simple.
just assume that that's a triangle.
Yeah.
So earlier from our measurements, I think we got that distance as 20 meters from when we measured it on the computer.
Yep, that was 20.
20
So from
meters.
here to there,
To there is 20 meters.
so that's 20.
And then we got the height as 9 meters.
The height,
9 meters.
9 meters.
So then what we need to do is find the area of that, which is using half base times height. So if we have half base times height, you have a half times the base, which is 20 meters, times the height, which is 9 meters, which is a half times 20, which is 10 times 90, which is 9 times, which is 90 meters squared is the area of the triangle. Now what we need to do is find the area of
the whole circle.
The area of the circle is just pi r squared. So we have pi times the radius of the circle, which is 18 squared. So we put it in the calculator. 18 squared times pi gives you
This is 1017.9.
1017.9 as the area of the circle. So then we do 1017.9 minus which is squared minus 90 meters squared. That will give us this area here, and then we can times that by the depth.
Depth, which is
So
2.
if you subtract 90 from that value on the calculator, that gives
927.9.
0.9. That gives us the area exactly of this area. Now we need to times that by 2 meters to get the depth.
Get the whole volume of
To get
the.
the whole volume of
that's
it. So 927.9 times 2 equals
1,855.8. Yeah.
So yeah, I think that gives you the depth here. I think would it become meters cubed then?
Then that's meters cubed. Yes, it will be meters cubed.
Oh, yeah, because we've done surface area is meters times
Yeah,
2 meters. So it's
Yeah,
meters
so
squared
meters squared times meters, which is meters cubed.
So the volume of the lake comes out in the end to be 1,855.8 meters cubed.
Problem solved.